be hampered now, not only by my febrile state, but also the fact that we are dealing with with a display situation that's also very adverse. Okay, so in my 470 class, I stood in front of the class, and for most of it, I held this thing with my hand, which was painful but operational, and I think I'll probably be undertaking the same strategy right now. Okay, so today I'm going to be speaking about value objects. We'll try innovating a bit. Hey, look at that. Okay, okay. So we're going to be talking about value objects. This is something that links in with some of the strategies that I've seen in your code, and in general. Historically, I've included this material because there's been a sense by students of falling into patterns where when you define classes or objects, something like JavaScript, there's been a focus on as using them as kind of structures with getters and setters, or putting data into them, taking it out. And because in so much of the way object-oriented techniques are taught, there's traditionally been an emphasis on, a structure, something that stores evolving data and methods to manipulate that data, but a lack of attention to the importance of what I call value objects, or immutable objects. These are objects that are immutable in the sense they don't change over time. And although you might think of that as a handicapped object, it's far from it. Sometimes these sort of objects can be incredibly valuable and much clearer to use. And unfortunately, I don't have time to go through certain background information on the effects of side effects because of the time I've taken to address project needs. I'm going to have to skip directly to some of the motivation and talk and introduce value objects. But one way of making your code clearer, more transparent, and actually more reliable for people to build atop of is through the use of immutable objects. Okay, these objects are often calculated by and returned by methods. And in Java, you'll find some of those objects well represented. An example would be the immutable pair class, which is supported by the Apache Lang libraries. String in Java is immutable. You can't modify a string. If you append it to something else, you get out a new string. And in many languages, some of these other, like complex numbers or vector, etc., will be often immutable. So maybe someone could get the left light thing back there. Just it's hard to see. Yeah, that's great. So let's look at an example of an immutable object, ladies and gentlemen. Here's an immutable object. It's a class complex. And how do we know that this is immutable? What do we look for here? Yeah, and it's the final associated with these guys here, right? These guys can't be updated. What does this final for the class as a whole mean?
Can't be subclass.
This can't be subclass, exactly. Now, there's good reasons for doing that with classes, because subclassing comes, the ability to subclass comes with certain heavy responsibilities, including documentation of the internal mechanisms of a class, as needed to make sure subclasses work properly. So it's good practice to limit subclassing, as you'll hear more about in 470. But here we have final marked for two fields, and that means they can be initialized in line here where you declare them, or in a constructor, but nowhere else, right? And This class, you'll notice, provides some useful functionality, the ability to add numbers, subtract, multiply, extract real imaginary parts of this number. But never does it modify this number. Once created, it represents this complex number, and you can add it to another, in which case you'll get back a different complex number. But there's no modifications going on here, okay? So why would we use value objects? Well, a couple reasons. They simplify reasoning. There's no concerns about sharing of these objects. Why not? Suppose I have an immutable object. Suppose other people point to it, or other people don't point to it. Why don't I care in terms of functionality? And let me ask this. Let me turn it around. Suppose I have a mutable object, an object that can be modified, such as many you've created for your projects. Why do I care whether or not other people are manipulating this object?
For example, if you have like a hash table,
Yeah.
you put an object with hash.
Yep.
You get hash with object, when you change it, the hash changes as well. So it's
Okay, so I like what Nobleman has said there. So one issue is, ladies and gentlemen, if others are pointing to this object, they may change the object out from under them in ways that I'm not aware of right now and that I want to be aware of, for example. I'd like to somehow subscribe to how they change things. Ooh, uh-oh, now we're in trouble. Okay, okay, there we go. Oh man. We live, ladies and gentlemen, in an analog world. Okay. Okay. So, it turns out that these sort of objects have less worries in terms of sharing. All methods are pure functions, meaning you call them, they do some action, they return a value, but they're free of external side effects. We, from an external party, look at the object, hasn't seen anything changed. They may manipulate caches inside or do other stuff internally for bookkeeping, but it doesn't change the behavior of the object. So that means we could call one of these methods many times and not expect any changes. We don't have to worry about call one thing before another or vice versa. And it turns out for subtyping, for creating a subtype of this, there's fewer worries to deal with. And indeed for subclassing. One of the most important things that I'm going to emphasize shortly is these can be used as building blocks for other data structures more easily. Okay? It really simplifies our life. We're building it out of an immutable object than a mutable object. If you're building things out of mutable objects, you have to go through various contortions to lower the risks. So if you're building an object in a library and you want it to be used, often having an immutable object will allow people to build things out of your object more readily. And then it turns out there's some efficiency benefits, okay? Particularly having to do with the sharing aspects and parallelism. Here's an example of sharing, okay? Okay, so if we have immutable strings, ladies and gentlemen, we can have the ability for us to reuse the same string representation by many parties, many independent parties, without worries one's going to clobber the string representation of another. More than that, if we have for example, an appended string, precondition here, we can have, this string reuse those components of this other. If these were mutable, there'd be the concern that, well, someone with str full might prob one of these items here and thereby change the string up from under it. But if we know they're immutable, we can go and reuse these, link them together with confidence that someone using this reference is not going to change what's being seen by this other reference, okay? There's no way they can interfere with each other. Or in big nums, consider big nums in Java. Probably you folks haven't used big nums before, but they can store information in a much more extensive way about the value of a floating point number. And with big nums in Java, you can reuse, for example, the minus of a big num is just, they only differ in terms of having this information and pointing to the underlying number. So if you take the minus of a number, it doesn't create a complete copy, it just takes the original number and has a minus here referred to the original number. Why? Because the original number is not going to be modified. It's immutable. Okay. Now, for subtyping, for the Liskov substitution principle that we talk more about in 470, but I mentioned here, there's fewer things to worry about. Okay. Post conditions involve return values. They don't change the actual object. So we don't have to worry as much about consistency of post conditions as long as the return values are compatible. And invariance, things that are true at one time, any one time, we don't have to keep on checking. If they're true at start, they're true on an ongoing basis. History property, it never changes. It's very, very simple. Okay. So let's talk about immutability in Java, and let's give some examples of where it's useful. So if we consider achieving immutability in Java, there's some aspects of it that are very straightforward, ladies and gentlemen. Declaring at this level a given class to be immutable is no problem. We simply mark fields as being final. We expose nothing that sets any values, etc. The challenge here, ladies and gentlemen, is not so much that there's a problem with doing this. It's very straightforward. One of the problems is that someone could subclass it in a way that it's not itself immutable. That would be a bad thing to do. It would violate the Liskov substitution principle, because we have something that could be, it looks like a complex number, but now it can be changed, which would throw off everyone's assumptions, operating only off this interface. They'd say there's no way that can change, but now it would be. So it'd be a violation of the Liskov substitution principle. But maybe to help guard against that, ladies and gentlemen, we can mark this class as final. Okay? Mark it as final, and it can't be subclassed. And that will rule out the possibility that someone has subclassed it. Okay? There's another way to do it. Make constructors private and use static initializers. Okay? Okay, now, this is one of the things I want to get to. This is where the rubber meets the road, and I want you to think about this. Okay, so here we have a class. In this class, ladies and gentlemen, is ostensibly a immutable class. Okay? How do I know it's immutable? Well, it would, by all appearances, seem immutable. We have these two final methods, and then we have methods in the class, start and end, that simply observe the values of these methods. They simply return the values of these methods. Nowhere in here in the class is anything setting the value of start and end except in the constructor. Now, noting that the class date is a mutable class, I want to ask you, is this class immutable? And why not?
Constructor for period as a reference to an object inside a class could possibly change.
That could possibly change. So perhaps it was our intention to create an immutable object here. But what we've actually created is mutable because it makes use of references to something that's mutable. Could you give me a concrete example if I build a period made of start and end dates here, and so I have a reference to this? Give me some way, so I have a reference to this period, okay? Points off to here with a certain start and end date. and then someone else has a reference Q to that same period. Maybe P, they've created this and they think it's going to stay the same. They don't have to check again some property of it or what have you. Could you give me an example about how person Q could actually modify the date range represented here in concrete terms? What could happen? Give me one scenario.
If you create the date objects before and then pass those to the constructor.
Good. And then what could...
And Q would already have a reference.
They'd already have a reference to one of these dates. So they're keeping this reference to the date. They create a period with respect to those dates, but then outside of this, they modify those dates, right? They have a reference to those dates separately. They passed in for this. But, you know, so they've got a reference already to the dates. They created a period, and they, by directly modifying those dates, now suddenly periods begin date has changed. Give me another concrete scenario. So I love that one. Give me another concrete scenario.
Someone really wanted to, you could probably use reflection to grab the start and end one, and then you have references again.
Okay, there is some opportunities for reflection, but there's something more easy than that. I mean, after all, you could ask for start, get back a date, and then what could you do with that? You could change it. Suddenly, period's start date has been changed without its permission because it returned a reference to that date, which it's counting on internally, and it's a mutable object. It's returned something that's a reference to a mutable object, and therefore, by extension, it is mutable. Do you understand that point? These things are mutable. Start is just a reference to some mutable object. And if someone calls start method and gets back a reference to that mutable object, they can then change that. And start here will be referring to that changed date. And poor period doesn't know anything about it. Doesn't know that the date changed. Maybe that person externally changes start to be after end date. Maybe as an invariant, start has to be before the end date, right? Look at this. In the constructor, start is the beginning, end is the end. It throws an exception in the constructor, start is after end. So it wants to guarantee that invariant that start is before end. But meanwhile, you call start method, you could just modify that date for start to be after end, and period's none the wiser. It doesn't know. Doesn't know suddenly you've changed the internals of its data structure. Could readily happen. Totally easy, right? You could do p dot start, p dot start, and then you could do, set year or whatever to be, 2100. Suddenly period is not only been changed out from under it, it has no idea, but suddenly its invariant has been modified. It's been violated, right? Its start is after its end. Bad news with a capital B. Okay. Same thing with end, of course, here. Okay? Because getting this back is actually referencing the same date that's referred to there. So what can we do to prevent that, ladies and gentlemen? How can we stop that from being a problem?
Have the constructor take the string instead and then convert it to a date.
Okay. Have the constructor. So fundamentally, have the constructor not reuse a date passed into it will be one clue.
And then you'd have to convert it when you're returning it to.
And then when you're returning it, you'd have to not return the date that's counted on internally. Because if the date that's counted on internally is mutable and you return the reference to it, suddenly you have opened up the internals to be changed, right? Okay, so there's two vulnerabilities here that have been identified, right? One is the constructor vulnerability. So, here, this is just as Evan was saying, you've got a start and an end, you pass it, you create a create an instance of the class, and then you can set, start to be something else, and it's modified the internals, right? Alternatively, you could, get the end and you could set it, right? So either way, you've got some vulnerabilities. So what are we going to do about this? So one way is you could pass in strings. That actually would work, but it might be kind of cumbersome. But it could be done. Now, let's consider this. So one possibility would be to do something like this. We could clone these. Why are there problems with this? We could pass in a date. So instead of a string, we could pass in a date. Maybe that's more convenient because we get a date out of some other structure, whatever. We pass in a date, but we clone it initially. Why is that an incomplete solution? What's the problem with this?
You still get a reference to it from the start.
I'm sorry?
You can still get a reference to it using the getters instead of the class.
Okay, yeah, so you're right about that. So Nobleman, you're exactly right. We still have this vulnerability. But why doesn't, for the constructor vulnerability, why doesn't this cut it? For those who are interested in security-based programming and preventing security problems, this is getting into that area. Why is this not a complete solution? We clone here. Well, okay. One issue is it is possible that something could there's a race condition. Just as you're calling this in, and this has been compared, but before it's cloned, it's actually changed right in that area, okay? This would be a violation of the invariant. So if you have a multi-threaded program, it is possible that something can be changed in this area. And you might say, well, what's the chance of that? Well, if you're on a heavily thrashing server that's dealing with high server load, race conditions can be big problems. Things can actually happen in here because it might be, 2 seconds before this happens. Unlikely, but possible. And believe me, when you're going really slowly, all sorts of things can happen. Okay. So one opportunity here is that we could do this clone before this, in which case the chance that something happens in here is very small, right? It could be that we clone it and then we compare, in which case we won't have this vulnerability here falling through. Okay. So this is possible. Certainly that would reduce the vulnerability, but the bigger vulnerability here, ladies and gentlemen, is the security vulnerability, and this has to do with malicious code. Okay, so look, we're saying clone here, and we're saying start.clone, end.clone. How could that clone go wrong? I'm going to tell you, you're not absolutely certain that the result of this is a true clone of date. Why not? What could we be dealing with here besides date itself? Well, you could deal with a subclass of date. A subclass whose clone just returns a reference to the original value. In which case, we are not going to be getting a true clone of this, in which case the person who is building this period may be deliberately wanting to get to the internals. So there's a problem here with vulnerabilities, with security. If you don't necessarily trust the code you're dealing with, this won't be a complete solution either, because this call to clone might not in fact create a true clone of this. So ladies and gentlemen, clones are not going to be a complete solution here. So how are we going to solve this? Well, this really gets down to Evan's suggestion, which is we're going to build a new date. Instead of depending on this existing date, we're going to create ourselves a new date structure. And evidence suggested a string, and that would do great. But another possibility is you do, new date, start.getTime, new date, end.getTime. This creates a date, and this is guaranteed to be a true date data structure, not a subclass of date, but a date. And then you can compare them. So you manufacture, ladies and gentlemen, your own dates, okay, out of this. Now you might say that's a lot of work. It is some work, but it eliminates these risks that we're trying to deal with here, but this is incomplete, okay? And it eliminates this constructor vulnerability. So in short, we have to build a new date. Why? Just because we're building this data structure out of something that's mutable. We cannot just take it in and use it as our internal reference, a reference to it for our internal fields. That would not be safe. We have to actually create a new thing here, just in case someone else has a reference to start as a reference to end. Inconvenient, yes, and that's just the point. If you are building your classes out of mutable structures, you will want to do this, to be careful, or else they can be changed out from under you, just like these things were changed out from under us without Period even knowing. Okay? So, ladies and gentlemen, okay, so we created a new date. Okay, now the second problem, ladies and gentlemen, is the Accessor vulnerability. It has to do with this problem here. How are we going to deal with that problem? Can anyone tell me? Advance a thought. Okay, do a new copy. Every time we return end or start, return something that's a copy of it, right? And indeed, we can do that. We can clone this and create a date. Notice start here. Why isn't this a security vulnerability? Start.clone.
Because you created it yourself.
Because we know it's a date. We know it's an actual, honest-to-goodness date object. Therefore, doing start.clone, we know it's a date. So we return this. A lot of work. That is exactly the point. Building things out of mutable pieces exposes you by default to risks. And you have to engage in this area that I would broadly call defensive copies. If you have a object that uses mutable objects internally, you need to make these copies. Now, ladies and gentlemen, you notice I say if an immutable object uses mutable objects internally, it needs to make these copies to stay immutable. If I build a mutable object, if I'm building up a mutable date, do I need to worry about this? Yes or no? Suppose I want to build up a mutable period, which does allow you to change start and enter, but always has the invariant start needs to be before enter. Will I need to do these defensive copies then?
Yes.
Yes. Why?
Because if you were using a subclass, they could have overwritten the compare functions.
Okay, subclass is one thing, but I would argue even without a subclass, if I were building a mutable date where I wish to allow, if I instead of this guy here, I wanted to allow a mutable period where I do allow changing over time of start and end, but I always need start to be before end. Why is it that I can't just, that I still have to undergo these defensive copies?
Because when they changed outside of class, you look
Yeah, exactly. If they could still do this sort of thing, change the start or end date outside of the class, and I'd have no way of checking my invariant, right? I want a mutable class, so yeah, I'm not bothered by start changing, but I at least want enough control over that class instance. So, if start is being changed, I make sure it's before end, right? And I lose that ability if I'm just willy-nilly handing out these references to these internal things. References to my end or references to my start date. If I'm handing these things out directly from my internal data structures, someone externally can just change them and I'll never know. I can't check this invariant. I can't even maintain my own data structures properly if people are accessing these things. So ladies and gentlemen, even if I'm building a mutable period, I've still got to do these defensive copies by and large because someone externally might change these things without me knowing, without being able to check my invariants, without being able to check if I'm sane. In general, you don't want, even if you're a mutable data structure, you don't want people just messing with your internals without your knowledge externally, okay? Okay, so, here we're dealing with this need to create copies of mutable objects referenced when passing objects in and out, okay? These include constructors, things that passing back data. And to be really vigilant, don't accept objects of non-final classes, duplicate via constructors. In short, it's a big pain. It's a big pain, okay? Okay, now it turns out that if you're building things out of immutable objects, they're more transparent. Why is that? Okay, suppose now that instead of dealing with this where we have date here, we have immutable date. Immutable date. It's a reference to instance of a class that cannot be changed. Instance once created, never be changed again. Do we have to make the defensive copies here? Do we have to make them in the constructor? Do we have to make them when calling start and end? So imagine if date here is not date, but immutable date. Would we have to have defensive copies all through here, and in the constructor? Why not? Nobleman's correct. We don't have to. Why not? Because we don't care how many people refer to these things. Why?
They can't change.
They can't change them. There could be 100,000 people looking at our start. They can't change it. How does that hurt us? How does that inconvenience us? If we point to the same immutable date as a billion other people do, doesn't matter to us. I mean, they're welcome to refer to it too. It's immutable. So, same to us. So, if you're building something out of immutable pieces, ladies and gentlemen, out of pieces that will not change, they're more convenient. You don't have to go through this defensive copies. You don't have to worry about this damage potentially caused by someone frothing your internals, changing your internal data structure, violating your invariants because they can change things within you. Regardless of whether you're mutable or immutable, those are bad things with a capital B. Okay? So it turns out that we don't have as much to worry about, that that other pieces of the code will modify things. Okay? So, ladies and gentlemen, in general, when we're dealing with building up data structures, we have a lot of benefits that can come by building things in an immutable way. Now, what does that mean in concrete terms? It means the constructor has all the information needed to build the object, and then the object is just maintained after that. If you need another object of that sort, you can create a new one that's appropriately modified. Just as back here, back here, we have a complex object, it's fully initialized here, and then if we add something to it, we return another object. If we subtract something to it, we return another object. But never are we modifying this, okay? So it's a desirable feature. So let me check the time here at the risk of upsetting this this thing here in terms of the display. Okay. Okay. Yeah, it's getting close. Well, one of the classic patterns for immutable. So immutable objects are all around us. And they're around us for good reason, because we build things out of them that are simple. Okay? And one of the classic patterns is this thing called the flyweight. And the flyweight is used when you have a very large number often. You need a very large number of pieces of information, but there's a lot of overlap between the pieces of information. An example would be a text document, where you have characters in fonts of various sorts, sizes, shape, bolding, italics, whatever. And you have a lot of needs for this in a document, but there's a lot of cases where you're going to have overlap. You're going to have A in the same font, lowercase a in the same font, many, many, many times. So rather than having, for each character, storing custom the information about for that particular character, what these are instead doing is they're pointing to the same flyweight object, the same object that represents A in a certain font, for example, okay? And so rather than having for each character successively in this document, A, B, C, D, E, this is not a good example, abracadabra, you will have these guys referring to common objects. So this might be A in a certain font, etc. Abracadabra. Okay, this one refers to it too. But meanwhile, this B and this B would refer to the same one, and this C refers to a different one, and this R refers to a different one. So here we have 4 flyweights representing different sort of subsets of the characters here. And we can have different fonts, in which case it'd be a different flyweight for versions of this character, not only for different characters, but the same character, different fonts. And these are immutable objects. Because they're immutable, we can have many characters refer to them. Many particular instances can refer to it, because this isn't going to change. This is going to be consistent in its value. We don't have to worry about it changing out from under us, okay? If one of these characters is bolded, let's suppose we bold this first character. So now we have it with A. Now what we're going to do is we're going to update this from pointing there, and it's going to point to something that has this A in a bolded sort of way. Okay. So basically, instead of storing these actual characters, all we're storing is references here. I wrote it out, but really what we'd have is a sequence of references. So instead of mutating this, we can't just mutate it, it's immutable. We create a new one and we refer to this there. And there's a huge amount of savings you can get. Think about 100 pages of text. By reusing these same ones again and again, we save a huge amount compared to custom encoding for each position, exactly what character it is, what font it's in, etc. Okay? So we can reuse these mechanisms in that sort of way. This is a classic pattern. It's called the flyweight pattern. It's been used in many systems, and it allows you to capture a lot of features in an immutable way that can be very, very valuable. Okay. Okay, I think this is all we have time to really cover. I will just say, be cautious when we talk about value objects, about what we mean. It's not true that so I use the term immutable, an immutable object. And that term is a little bit of a fiction. What it really means is there's no externally visible side effects. Internally, this object might be modified. Internally, it might make use of data structures like a cache, which gets updated to keep the most recent value that was grabbed or looked up or what have you. Internally, it may be modifying things, but from the point of view of the external world, it's immutable. There's a cache that means how quickly you get a value back from it, but you always get the same values back. Just sometimes it takes longer than others. So when we say immutable, what we really mean is that for the purposes of someone who's outside the object, it seems immutable. Okay, there may be purely internal visible state changes. It's optimizing an internal data structure and what have you. But it's doing so in a way that people externally can't see. So, you know, there may be a caching, like if you have a long string, it caches its hash code, hashed value, and that's updated the first time it caches it. But from the standpoint of the external person, if they ask for its hash, it returns a hash. They can't tell it's being updated. Okay, so that's all for today. Thank you very much for your patience, for bearing with my croaky voice. And to be honest, I saw my doctor yesterday, and he's urged me serious bed rest. I'm not sure what's going to happen for the next week. Worst case, there may be guest lectures or videos. Okay, so we're going to have to bear with that, and I apologize. But I may be with you next week as well. So just no pause. We're going to see what the next week is. Okay, thank you.
I emailed equipment services during this, and they said